Have you ever looked around you at a solid rock, a flowing river, or even just the air that you're breathing and wondered, what is all this stuff actually made of? Well, today we are going on an incredible journey to answer that exact question. We're going to shrink way, way down and explore the secret, invisible world that builds absolutely everything.
All right, so here's our game plan. We're going to start with some simple questions that have some really surprising answers. Then we'll see what happens when we start breaking things down. After that, we'll meet the three main families of matter, discover the hidden spaces between them, and finally, we'll uncover the amazing fact that nothing, and I mean nothing, is ever truly still. Let's get started.
So, first up, what is everything made of? To answer this, we don't need some fancy high-tech lab. All we really need is a little bit of curiosity, because the world is just full of these amazing puzzles if you know where to look. I mean, really think about it for a second. Why can you make a pile of sand, but you can't make a pile of water? And how does air, which is completely invisible, have enough weight to actually fill up a balloon? Now, these might seem like simple questions, but they're pointing us toward a massive scientific secret about what everything is made of.
When you look at a scene like this, you see solids like the rocks, you see a liquid, the water, and you know there's a gas, the air, all around them. They seem totally different, right? Well, it turns out they all share one fundamental secret, and that's exactly what we're here to uncover.
So, how do we start to prove any of this? Well, our first clue comes from a really simple idea that big things are just a collection of lots and lots of tiny little pieces. Let's check this out with a simple thought experiment.
Okay, imagine you've got a stick of chalk. You snap it in half. Easy. Then you take those pieces and you crush them, you grind them down into a super fine white powder. Now, if you looked at that powder with a magnifying glass, what would you see? You'd see thousands of tiny, tiny little grains.
So on the left, that's our starting point, one solid stick of chalk. And on the right, the result, a pile of fine powder. But here's the really important part. Even though it looks totally different, every single one of those tiny grains is still chalk. We've just changed its form, not what it fundamentally is. And this super simple experiment reveals a huge truth. All matter is made of tiny building blocks. Scientists have a name for them, of course. They're called constituent particles. These are the incredibly small units that come together to form everything, from that piece of chalk to a mountain to a river, and even the air itself. Okay, so everything is made of particles. Got it. But if that's true, then why are some things hard and solid while other things are runny and splashy? Well, it all comes down to how those particles are arranged. And this gives matter its three main families, or what we call states: solids, liquids, and gases. First up, solids. In a solid, the particles are packed together incredibly tightly, almost like soldiers standing in perfect formation. They're locked in place, and they can't do much more than just vibrate a little bit. This super rigid structure is what gives solids, like a key or a stone, their definite fixed shape. They just hold their form. Now let's loosen things up a bit with liquids. Here, the particles are still pretty close, but they aren't locked into place anymore. They've got enough freedom to slip and slide right past each other. And that is exactly why liquids can flow and take the shape of whatever container you pour them into.
And finally, we have gases. The particles in a gas are just chaotic and full of energy. They're spread really far apart, and they're zipping around randomly in all directions, bouncing off each other and the walls of their container. This is why a gas will always, always expand to fill any space it's in, no matter how big. This table pulls it all together perfectly. Just check out the key differences. The spacing between particles goes from being minimal in solids to the absolute maximum in gases. That attraction, the sort of glue holding them together, is strongest in solids and practically non-existent in gases. And that directly controls how they move, from just a simple vibration to having complete and total freedom. Okay, so what about the space between all these particles? This whole idea of invisible gaps is our next clue. And honestly, it helps explain some things that kind of look like everyday magic. So here's a classic puzzle. You stir sugar into your drink. The sugar crystals completely vanish, but you know they're still there because the whole drink tastes sweet now. So where did they go? Did they just magically disappear? No way. The answer is actually so cool. The tiny little sugar particles break apart and they just slot themselves into the empty gaps that are between the water particles. Scientists call these gaps interparticle spaces. This proves that even something that looks totally full, like a glass of water, is actually filled with tiny empty pockets. Right. But this leads to another really important question. If everything is made of separate particles with all these empty spaces between them, what's holding them together? I mean, what stops the particles in the chair you're sitting on from just drifting apart? The answer is an invisible force called interparticle attraction. You can think of it like a constant magnetic pull between all the particles. This attraction is incredibly strong in solids. That's what locks them together. But it's extremely weak in gases, which allows them to fly free. This force is pretty much the glue holding our entire physical world together. And now for our final, and maybe the most mind-bending piece of this whole puzzle. It turns out that nothing is ever truly still. Down at the microscopic level, all particles are in constant, restless motion. That's right, the particles in your desk right now are vibrating. The particles in a glass of water are sloshing around. And if you add heat, you give them even more energy, which makes them move even faster. This is exactly why a drop of food coloring spreads so slowly in cold water, but just zips through hot water in a matter of seconds. And this whole principle of constant motion explains so many things we see every day. When someone sprays perfume, those little fragrance particles are in a gas state. They immediately start zipping randomly through the air, spreading across the room, until eventually they find their way to your nose. It's not magic at all. It's just particle motion in action. So let's do a quick recap of the 4 fundamental secrets we've uncovered today. Number 1, everything is made of tiny particles. 2, how they're arranged determines if something's a solid, liquid, or gas. 3, there are always empty spaces between them. And 4, the coolest part, those particles are always on the move. So, now you know the fundamental secret of all matter. With that in mind, I'm going to leave you with one final thought to ponder. The next time you see ice melting, or water boiling, or you smell cookies baking in the oven, just think about the invisible dance of particles that's making it all happen. How does knowing this change the way you see the world? Thanks for joining us for this explainer.